Sayed and Mass Online. Today's topic will be radius of curvature. In the previous video, you learned the definition of radius of curvature, and we have done few problems on radius of curvature in the Cartesian form. Today we'll continue with few more problems on radius of curvature in the Cartesian form. Let us start with the first question. The first question is, find the radius of curvature for the curve y square is equals to 4a square times of 2a minus of x divided by x, where the curve meets the x-axis. It is given that the curve meets the x-axis. So if the curve meets the x-axis, then on the x-axis the value of y will be equals to 0. So if y is 0, then the curve becomes, therefore, so if you put 0 in the given curve, y square is there, so that becomes equals to 0, is equals to, we have 4a square times of, it is 2a minus of x, is the whole divided by x, or it can be further rewritten as 4a square times of 2a minus of x will be equals to, just cross multiply this x on the other side, x times of 0 will be 0, or you can just write 2a minus of x is equals to, send that 4a square on the other side, it becomes 0, or over here we have minus of x is equals to, send this 2a on the other side, becomes minus of 2a, the negative sign will cancel out, you'll just be getting the value of x to be equals to 2a. So hence we have got the values of x and y. So x value that we have is 2a and y value that we have is 0. So x comma y is nothing but 2a comma 0. So let us move on to the given curve. The curve that is given is, so given the curve y square is equals to 4a square times of 2a minus of x is whole divided by x. So we just try to multiply the numerator. Multiply 4a square with 2a, you will be getting 8a cube minus of 4a square times of x will be 4a square x is whole divided by x. Divide x for each of the terms. It is 8a cube divided by x minus of 4a square x divided by x. You see that the value of x and x will cancel out. Will be left out with 8a cube divided by x minus of 4a square. So that is the value of y square. So let us take this as equation number 1. We'll differentiate this with respect to x. Derivative of y square will be 2 times of y, and derivative of y will be dy by dx, or we can write that as y1, that is equals to, on the right hand side, 8a cube, will write it as it is, 1 by x is there, so differentiation of 1 by x will be minus 1 by x square, minus 4a square is a constant, so derivative will be 0. You can cancel out 2 1 times and 2 4 times. So we'll be getting the value of y1 to be equals to, so you can see here you have minus 4 a cube divided by x square. You can cross multiply that y, you will be getting in the denominator here. So y1 value is minus 4 a cube by x square y. Now I need to find out this y1 at the point 2a comma 0. So the value of y1 will be equals to minus 4a cube divided by x square value is 2a. So 2a whole square into the value of y is 0. Since 0 is in the denominator, so anything divided by 0 will give infinity. So this value will tend to infinity. If y1 is infinity, then the radius of curvature will also tend to infinity. So we want the finite radius of curvature. So therefore, we cannot find out this y1 and y2 value. Rather, we have to go for the radius of curvature formula. So rather, instead of finding this y1, we need to find out the value of x1, and instead of finding y2, we need to find out the value of x2. So we need to find out x1 and x2. So to find out x1 and x2, we have to differentiate this given equation number 1 with respect to y, so that we can use the radius of curvature formula. The radius of curvature formula, rho to be equals to 1 plus x1 square to the power of 3 by 2 divided by x2. You can use this formula. The details about this formula I have given in my previous video. You can watch my previous video for this formula. So just rewritten that formula again over here. Rho to be equals to 1 plus x1 square to the power of 3 by 2 whole divided by x2. Let me take this as equation number 2. So we'll try to differentiate equation 1. Differentiate equation number 1 with respect to y. So you can see that this equation 1 is y square is equals to 8a cube by x minus 4a square. So let us try to differentiate this one. Derivative of y square will be 2y is equals to, you have 8a cube is divided by x. So 1 by x differentiation will be minus 1 by x square into differentiation of x will be dx by dy, or you can write it as x1. So since I'm differentiating with respect to y, we get derivative of x to be equals to dx by dy. Minus you have 4a square, it's a constant, so derivative will be 0. So from here I need to find out the value of x1. Just cancel out to 1 times and 2 4 times. So further, to find out the value of x1, you can just cross multiply this value. You are getting x1 to be equals to, so cross multiply this value on the other side, you'll be getting the value to be equals to x square y, that's whole divided by, so here you're getting minus 4 a cube, so minus sign will be as it is, you'll be getting the value to be equals to 4a cube. So x1 value we got it as minus x square y divided by 4 a cube. Now at the point 2a comma 0, I'll be getting the value of x1 to be equals to minus of x value is 2a, so it is 2a square, y value is 0. So since it is multiplied by 0, the value of x1 will be equals to 0. Let us take this as equation number 3. So to get the value of x2, we have to differentiate this equation number 3 with respect to y. So derivative of x1 will be x2 is equals to minus of 1 by 4a cube is a constant. I'll take it outside. Then differentiation of x square y, it's a product rule that I need to apply. X square as it is, differentiation of y with respect to y will be 1 plus keeping y as it is, differentiation of x square will be 2x into differentiation of x with respect to y will be x1. Or further, if you try to simplify, it is minus 1 by 4a cube, you have x square plus you have 2x x1 y. At the point 2a comma 0, let us try to find out the value of x2. x2 will be minus 1 by 4a cube, x value is 2a, so 2a square plus, since we know the value of y is 0 over here, so 0 into anything will be 0 itself. So therefore we have got the value to be equals to minus of, this becomes 4a square divided by 4a cube. You can cancel out this 4 and 4. A square will also cancel out, 1a will be left out. Therefore we'll be getting the value to be equals to minus 1 by a. So we got x1 as well as x2. So let us just substitute these values of x1 and x2 in the radius of curvature. So radius of curvature is given by equation number 2. So we'll try to substitute in equation number 2. We get rho to be equals to 1 plus x1 square. x1 value we got it as 0 to the power of 3 by 2 whole divided by x2. x2 value is minus 1 by a. Therefore, you got rho to be equals to, in the numerator it is 1 power of 3 by 2 will be 1 itself, and in the denominator you are having minus 1 by a. So minus 1 by a, if I take in the numerator, it becomes minus of a. So you get the radius of curvature rho to be equals to minus of a. But since the radius of curvature represents the length, it cannot be negative. So therefore we'll be taking the modulus on both the sides. So we get the radius of curvature to be equals to a. So that will be the required solution. Let us move on to the next question. Next question is, for the curve y is equals to ax by a plus x, show that 2 rho by a whole power of 2 by 3 is equals to x by y whole square plus y by x whole square. So we see that over here radius of curvature rho is present. So first we'll try to find out the radius of curvature and try to prove this particular result. For that, let us take the given curve. So the curve y is equals to ax by a plus x. So let us try to differentiate this with respect to x. Differentiate with respect to x. Let me take this as equation number 1. So if I try to differentiate this with respect to x, I will get y1 is equals to. Now since you have ax by a plus x, u by v form, we need to use the quotient rule. So if you're using the quotient rule, the formula that you have is d by dx of u by v is equals to, it is vu dash minus uv dash divided by v square. So let us try to use this one. V value in this case is a plus x, so it is a plus x times of u dash. So differentiation of ax will be a minus u value is ax into differentiation of v, a plus x differentiation will be just 1 whole divided by v square. That means the denominator square a plus x whole square. If I try to simplify this one, just multiply this a inside. I'll be getting a into a will be a square plus a into x minus this term over here is ax whole divided by, we have a plus x whole square. Further you can see that plus ax and minus ax will cancel out. We get the value of y1 to be equals to a square divided by a plus x whole square. Further, we'll try to differentiate this y1 with respect to x. So differentiate with respect to x. So we get y2 to be equals to, now a square is a constant. Now this expression is in the form of 1 by x square form. So you can write down its differentiation to be equals to minus 2 by a plus x whole cube, because differentiation of 1 by x square will be minus 2 by x cube. So I have written it as minus 2 by a plus x whole cube into differentiation of a plus x will be 1. Therefore, I have got the value to be equals to minus of 2a square divided by a plus x whole cube. So we got the value of y2. So let me take this y1 to be equation number 2, y2 to be equation number 3. So we need to substitute these values of y1 and y2 in the radius of curvature. So radius of curvature rho will be equals to 1 plus y1 square to the power of 3 by 2 whole divided by y2. So let us try to plug in the values. 1 plus The value of y1 that we have is a square by a plus x whole square. But in the formula we have y1 square, so you need to square this value. It is whole power of 3 by 2. It is whole divided by y2. The value of y2 that we have is minus 2a square by a plus x cube. So let us try to simplify this one. This will be equals to 1 plus, now since this expression that we have is whole square, so square this value, will be getting a power of 4 divided by is a plus x whole power of 4, and this is to the power of 3 by 2. There is whole divided by the denominator value that you have. So if I try to simplify this one, it comes in the numerator and you can write it as a plus x whole cube divided by minus of 2a square. So it becomes reciprocal when it comes to the numerator. Now this will be equals to, if I take the LCM in this case, LCM is a plus x to the power of 4. So just cross multiply this one. Just cross multiply, you get the value to be equals to a plus x to the power of 4 plus this a power of 4 will be as it is. That is to the power of 3 by 2 into this expression as it is a plus x whole cube divided by minus of 2a square. If you apply this power 3 by 2 to the numerator as well as the denominator, we get a plus x to the power of 4 plus a power of 4 to the power of 3 by 2. It is whole divided by the denominator value a plus x to the power of 4, and this is raised to the power of 3 by 2 into this expression as it is a plus x whole cube divided by minus of 2a square. Further, you can see that this will cancel out to 1 times and 2 times. This will be equals to a plus x to the power of 4 plus a power of 4 to the power of 3 by 2 whole divided by a plus x to the power of, you can just multiply this, 2 times of 3 will become 6. This expression as it is a plus x to the power of 3 whole divided by minus of 2a square. You just cancel out this one, a plus x whole cube will cancel out with this one, and to the power of 3 will be left out. This will be equals to a plus x to the power of 4 plus a power of 4 to the power of 3 by 2, that is whole divided by, just multiply this minus 2a square, will be getting minus 2a square times of a plus x whole cube, and this is the radius of curvature we have got. But if you try to observe, the result that we need to prove is, so we have to prove 2 rho by a to the power of 2 by 3. So you have to get 2 rho on the left hand side. So you have to get 2 on the other side, and also it has to be raised to the power of 2 by 3. So since you have 2 in the denominator over here, you can just cross multiply this 2 on the other side. So you'll be getting minus 2 times of rho is equals to, it is a plus x to the power of 4 plus a power of 4 to the power of 3 by 2. That is whole divided by a square times of a plus x whole cube. Now we have to get to the power of 2 by 3. So therefore raised to the power of 2 by 3. Raised to power 2 by 3. So that this 3 by 2 will cancel out with this 2 by 3, and this power will cancel out on the right hand side. So we have minus 2 rho to the power of 2 by 3, this will be equals to, it is a plus x to the power of 4 plus a power of 4 to the power of 3 by 2, and that is raised to the power of 2 by 3. In the denominator also you have a square a plus x whole cube raised to the power of 2 by 3. So we can see that this 3 and 3 will cancel out, this 2 and 2 will cancel out. And on the left hand side, if you try to observe, it is minus 2 rho to the power of 2 by 3 can be written as 2 rho to the power of 2 by 3. You're having a negative value to the even power, power 2, right? So whenever you have power 2, the value will become positive. Like if you have minus 2 raised to the power of 2, you can write this value to be equals to 2 square, positive 2 square. So in the same way, you can write here minus 2 rho to the power of 2 by 3 can be written as plus 2 rho to the power of 2 by 3. So therefore, on the left hand side, we have 2 rho to the power of 2 by 3. That will be equals to a plus x to the power of 4 plus a power of 4. That is whole divided by denominator is raised to the power of 2. This is a square to the power of 2 by 3. So it is a square to the power of 2 by 3. So this will be equals to a power of, just multiply 2 times of 2 will be 4. So we'll be getting 4 by 3. So a power of 4 by 3 times of you have a plus x to the power of, over this 3 and 3 will cancel out, you'll be getting power 2. Further, if you try to simplify this expression, I'll take this 1 by a power of 4 by 3 outside and try to divide this a plus x whole square for both the terms in the numerator. So if you just try to divide it, I will be getting a plus x to the power of 4, and that is divided by a plus x whole square plus a power of 4 is being divided by a plus x whole square. You can further see this a plus x whole square will cancel out to the power of 4 and becomes power 2. This will be equals to 1 by a power of 4 by 3. It is a plus x whole square plus it is a power of 4 divided by a plus x whole square. If you try to see the final solution that we need to prove, in the final solution we don't have a plus x, rather we are having the expression in terms of x and y. So since here you don't have y, you have to introduce the value of y. So we'll go back to the question and try to get the value of y. So we have the value of y to be equals to ax by a plus x. So here let us try to replace this value of a plus x by y value. So just try to cross multiply this one. If we cross multiply, we'll be getting a plus x to be equals to ax by y. So in place of a plus x, you can replace the value as ax by y. So therefore we have, it is 2 rho to the power of 2 by 3 is equals to, it is 1 by a power of 4 by 3. This becomes ax by y whole square plus a power of 4 divided by a plus x is ax by y and it is squared. This will be equals to 1 by a power of 4 by 3, and if you square this, you'll be getting a square, and x square and y square you have. Instead, you can write x by y whole square. So keep the square for x and y common. Plus, here you have a power of 4 divided by. Now, since you are having a, you can square that one, a square. Along with that, we have x by y whole square in the denominator. If I take that in the numerator, it becomes reciprocal y by x whole square. You can see that this a square will cancel out with a power of 4, it becomes a square over here. So if you try to observe here, a square is common in both the terms. I'll take a square as common outside and divided by a power of 4 by 3 as it is. So here we are left out with x by y whole square plus y by x whole square. So let us try to simplify this term over here. A square to the power of 4 by 3. So since we are having a square, so I can take this a square into a power of 4 by 3. If I take in the numerator, it becomes minus 4 by 3. Now since the bases are the same, you can just add the powers. A power of 2 minus 4 by 3. That is a power of, if I am taking the LCM, it becomes 6 minus of 4. So it becomes a power of 2 by 3. So this value can be replaced by a power of 2 by 3. So a power of 2 by 3, and this value as it is x by y whole square plus y by x whole square. Now a power of 2 by 3, you can send it on the other side. It becomes 2 rho to the power of 2 by 3 divided by a power of 2 by 3 is equals to, it is x by y whole square plus y by x whole square. So since the denominator and numerator are having the same power, 2 by 3, you can just put it as a common power, 2 rho by a whole power of 2 by 3. That will be equals to x by y whole square plus y by x whole square. So that is the required solution. So that's all I have for today. Thank you.